It was at this point that I got sad, so I went inside the house and just thought about life. Nah, I'm playing. I frantically tried to fix the problem. What's up everybody, it's Izzo, and welcome to the lab for devlog 15. That's crazy, we're 15 devlogs in. I hope you guys have enjoyed the lab as much as I've enjoyed sharing what goes on, and my biggest thanks to everyone for tuning in. The last couple videos did amazing, so thanks for hanging out in the lab everyone. Anyways, we're back to Codename All Night for the third installment of the Expulsion of Lag Series 2. Wow, that's a lot of numbers. Anyways, the next item on the bug list is skeleton entities. Our first focus is going to be reducing some of the calculations that the skeleton entity does, hopefully reducing the lag that they cause. Little side note, for today's project I tried to stuff as much game development in as I could. I hope that makes sense later on, so for right now, let's just jump in. So, before we can begin, we need a good environment to test the skeletons in. The perfect candidate for that is the graveyard environment. Literally, there's like 4 gravestones per chunk, so yeah, perfect candidate. The problem? There's no command to spawn it in, so we have to start there by adding a command to the debugger to force the graveyard to generate. We implemented the debugger in a whole series, actually at the beginning of the devlogs, so if you haven't checked it out yet, go ahead and tune in. With the new command added in, it's time for a series of tests to pretty much locate the lag. This was supposed to be a pretty straightforward test, spawning one graveyard, another random environment, and then another graveyard. Well, on that test, this happened. I don't even know if it showed well enough, but there was a major lag spike without any skeletons being spawned in. And to make it worse, I tried to check the frame rate, or the FPS, with the built-in debugger, which just made the lag worse. So now we have new additions to the test. First, we need to track the FPS without the built-in debugger. Tracking it within our custom debugger is the best answer, for now anyways. Next, we have to check the farm and watch the moo-moos. Those were the only things that were really active last session and really could have caused the lag. All we're gonna do is run around with the cows and every so often check the FPS. If everything goes well, it should stay at 60. If there's something wrong, it will drop or it'll fluctuate. Okay, so I guess it wasn't the farm or the cows. Everything looks good with the FPS there. That's a good thing, but also worrisome, because where did the lag come from then? Well, let's hope it doesn't happen again and move back to the regular mission. Alright, we're back in the first world we started testing with. This time, we're really testing the skeletons for frame drops. With our custom debugger tracking the FPS, this should be a piece of cake. Same thing as the cows, we're just gonna run around and check the FPS every so often to see what it does. Not good. It looks like as soon as these guys start spawning in, the frame rate dropped to around 40 or 50 FPS. Alright, let's get rid of this guy for the lag he's causing and then get to fixing the situation. In total, I've isolated it down to 3 places we can reduce some calculations and hopefully stop that bottleneck. Basically, the lag is caused because of the number of calculations happening per cycle of the game per skeleton. First, a value called speed checker is constantly set. We're gonna fix that with loops. That's looking much better. Second on the list, despawning mechanics. Basically what happens when the skeleton spends too long without being interacted with in a world. Right now, it's a value that counts down every cycle per skeleton. That's extremely inefficient, and honestly, we can do better. We're going to start by using the day count as a despawn value. When the day count hits a different day, every skeleton spawned the previous day will despawn. Alright, we should know what time it is. It's time to test these changes. We're loading in the same test since, saving and loading works now. Almost a year ago, but we fixed that in the lab, so make sure to tune in if you haven't already. This test is simple. We just need to make sure that the skeletons still spawn incorrectly and that they're moving, since those are 2 things that we just altered. Alright, we're looking good. They still spawn incorrectly and they also still move. Alright, let's keep it moving. Now it's time for the biggest change of this segment, which is the skeleton's movement mechanics. Right now, it's a value that continuously counts down, and it does this for every instance of the skeleton or individual skeleton object. The goal here is to have one value that controls the switching of directions. The result will be the elimination of potentially 20 to 30 objects that continuously count down. That's some relief to the runtime that we really need. Side note, I'm a little iffy about this kind of change. It takes the randomness out of the skeleton group and the way that they move. My worst fear is that they will all turn around at the same time, which would really just kill this aspect of gameplay. So our mission above all else is to stop the worst case from happening. If it does end up happening, we'll just undo the changes. Okay, after all of that, it's time to test these changes. The test is simple. We have to make sure these guys still switch directions every so often, and we'll do that by just following a skeleton for a while. So let's get some skeletons in the game. It was here that I realized that it's been way too long for this guy to have not changed directions. So I whipped out the debugger to track the timer's value, and this happened. Yep, the skeleton just ran off the screen. Not good in the least. It was at this point that I got sad, so I went inside the house and just thought about life. Nah, I'm playing. I frantically tried to fix the problem. And it took a lot of tries and tweaking to get this right. For fun, let's play a game and see how many tests it takes to fix this. Round 1, it was the simple change of taking out one check. Nothing happened, the skeletons still weren't responding to switching directions. Back to the drawing board for round 2. Now I needed to test if the loop was bad or if the skeleton's response to the loop was bad. Test 2 produced some helpful information. First off, the loop is firing off correctly according to the debugger here. At the same time, the skeletons are not responding to their values being changed, which should change their direction. Basically, it's the skeletons, not the loop. Now, for round 3. This time, I compared the old logic to the new logic. Then it clicked. Step counter, the old value, doubled as a value to refresh the event and check for changes again. Time for test 3 on a new world. The old world kind of broke. Yeah, I broke it off camera. Sorry everyone. Anyways, let's get some skeletons spawned in. Okay, it still doesn't work. Time for round 4. Let's get some skeletons spawned in and see what they do. Oh, we got it this time. Their directions are flipping over and over, and it looks like they are making the decision independently too. Success has finally been achieved. Alright, it's time for part 2, redesigning the skeleton. Funny thing, it's still using the design from the very first version of Codename All Night, and that's no good, it's gotta match our current vibe. As always, I got a plan laid out for us. Step 1 is that overall design, basically an outline for our skeleton. Step 2 is the color and the detail. Step 3, we're gonna animate this guy. Step 4 is testing and revisions. Step 5 is bringing it all back into the game. Alright, I think that's enough talking. Let's get started. So, we're in Sprite and we're just gonna start by trying to combine the newer character designs with the skeleton type of design. The thought process here is somehow we'll end up with the skeleton design that fits that new art style of Codename All Night. Wait. This is looking really familiar. Yeah, just as I thought, we're just repeating the design we already have. I have an idea though. Let's see what this candy cane looking shape can do for us. Ooh, okay, much better. We actually have a rib cage looking thing going on, and that's great. Let's keep going and see where this takes us. We're taking the foot from the human nature model and we're using it as a reference point. In a way, I kinda want the monsters of the game to share some type of design points. Alright, here's what we got so far for the feet. Legit, they're just smaller versions of the human nature model's foot. Anyways, I had some inspiration for the walking animation, so with a semi-finished Sprite, it's the perfect time to test it out in a typical lab fashion. Now, you might ask, what does testing an animation look like? Well, like this. Look at that, I like how this is coming out so far. Alright, it's time to move on to the face. The way I like to approach designing faces is by using the subtractive process. Basically, starting with the blob or a shape and then you sculpt it or take away from it in order to produce a design. Alright, I got so far on camera and then I had to stop the process because it got a little messy. And I didn't want to try to record and edit that, just gonna be honest. But here we are with the full design for the skeleton's face. Look at it, it's even got little teeth thingies too. Okay, we got one more body part left, the arm. Once again, we're borrowing an arm from the human nature model as a starting point. For our design, we want a skinnier, longer arm, something that looks like, you know, skeleton-like. Here we are, an arm that fits our model a little skinnier and a little longer, just like the order asked for. And with that, we have a full design for our skeleton model, meaning step 1 is complete. Time for step 2, coloring, I mean detailing the model. Anyways, we need a color scheme to follow. So for Codename All Night's graphic overhaul, the palette I used and derived all other colors from is the NES color palette. So that's what we're using here as well. And we just need white and a bunch of its shades because, well, bones are white. So yeah, let's do this. First, let's apply the base color. Next up, we'll add some details and shading using a darker color. We're really trying to achieve a more popping effect when it comes to the bones. That way it gives it a more like 1.5, 2, 3D effect. There we go. I'd say that we're getting there for sure. Let's keep it going and get some shading and details going on the face. This part I try to make pretty simple because, spoiler alert, I'm still pretty green when it comes to shading. Alright, here's what we got. Basically, my technique for this is to put most of the shading on the back side of the face. Now it's time for the arm. Pretty much, it's the same steps. First, we get the outline going. Oh yeah, quick note about my outlines. I repeat, I do not use black for my outlines. First, when I learned pixel art, the material I was studying said don't. But even when I found out it's okay and actually helps things pop from time to time, I was already scared to use it. My old sprites really overused it, and I'm just really not trying to go back to that. Anyways, here we are, the full arm design. And now we have a full sprite, but we are far from done. Next up, the animations. Pretty much, I stick to the same technique for animating any characters that are walking or running. There's always 3 frames, including the one we just made. The next frame, most of the model, including the body, or in this case, the bones of the skeleton, the head, and the eyes are all moved up. The third frame, everything that I just listed off moves down. The arms are a more complicated matter. I try to follow the same pattern of moving one arm up and another arm down, but I wanted a different effect for the skeleton model. So the second frame, for the most part, we move the arm up. And for the third frame, we move the front part of the arm up, and then we move the arm forward. When we try the animation, it looks something like this. It almost looks like he's reaching for something. The last change to the animation is adjusting the shading. This one is something I kinda just feel out. My biggest goal is to make sure the shading across all 3 frames adds to that motion effect. When all the changes are said and done, this is what we end up with. I'm not gonna lie, this little guy looks lit. Look at him, he looks like he's dancing. Alright, we're ready for the next step, which is trying to bring in the new design to the game. And the first attempt sent me back to Sprite. Our first model was just too small. So, back to the drawing board we go. The only thing we're going to do is add another one of these candy cane shapes to the skeleton. That should extend its height by a few pixels. Of course, a consequence of this is having to redo the design and its animations. So let's just get to the part where we test the new design. Ah, the magic of editing and not using all the clips I had recorded. So this time we only finished 1 frame and we're gonna test this 1 frame instead of doing all of the work and having to go back and do it again. I'm not gonna lie, doing that once already hurt and it irritated me a little bit, so let's try not to repeat that. Anyways, we're looking good here. I like the sizing of this much better. Alright, we're in the last stretch of this. I handled the other 2 frames of the walking animation off camera. Now we're just bringing in each animation, prepping it for gameplay. In the case of the skeletons, it's pretty simple. That has a lot to do with the simplicity in their behavior, I won't lie to you guys. All they have to do is walk around for a day and then despawn. There's not much to that. And here we are, back in our test world, forcing more skeletons to spawn. This time, we're testing the full animation and if the skeletons are visually a good fit for the world. Lab, we have a problem. The animation isn't looping. I think I forgot to set the animation settings. Yep, I forgot. Whoops. Alright, let's run that back and test this one more time. Look at that, new design and a better fit to the world. And a bonus, at least for me, their design makes me want to shoot them really badly. Dang, I want you guys to try this just so you can see what I mean. But anyways, we did it. Fixed AI and an overall skeleton sprite. Wow. Today has been packed. I mean, new debugger commands, reduced lag from skeletons, and the cherry on top of that cake, new designs for the skeletons. Wait, does the cherry go on cake or pie? And anyways, today has been a successful one in the lab for sure. I hope everyone enjoyed that too. There's a lot that goes into putting new enemies in the game and even just fixing an existing enemy. Like I promised, I was trying to include as much as possible. It was kind of a personal challenge, honestly. Anyways, I'm rambling now, so thanks everyone for joining me in the lab today. Leave a like if you enjoyed today's lab project. Let me know what you think in the comments and subscribe to join me in the lab for more experiments. Alright guys, have a good one and I'll see you for the next one. First the logic or the code for the enemy, then the redesign, then the animation, then the code again, just to make sure the animation works, and in between all of that, you got testing.